Okay, question 27 is another question on the coordinate plane. And this time we are asked to find the distance between points A here and B there. So we're looking for that side length. And what they have done here is they have formed a right triangle on the coordinate plane. And they've done us a good favor on this one in that they've put the coordinates directly on an ordered pair. So we don't have to really guess. We can just count the sides of this right triangle. And they're wanting us to use the Pythagorean theorem here. I'm going to, we'll talk about it that way. We'll talk about a couple of special right triangles. And then we'll also discuss how we can just reason through this one and come up with the right answer. So first let's count the side lengths, and these units will be, so 1, 2, 3, 4, 5, 6, 7, 8. So this side is 8 units. And 1, 2, 3, 4, 5, 6. So this side is 6 units. So we're going to use the 8 and the 6. And if we use that in Pythagorean theorem, we would do 8 squared. I'll go ahead and write it all out here. So we would do 8 squared plus 6 squared is going to equal c squared. In this case, we're looking for the hypotenuse. Here's our right angle. We draw a line. We're looking for c squared, and we know two of the legs. Excuse me. So this is 64 plus 36. Again, remember, this is not 8 times 2, but 8 times 8. All right, and this is going to equal c squared. This would be 100 equals c squared. And then the very last step in the Pythagorean theorem is to take the square root of both sides in order to isolate c. So 10 would be equal to c, or in this case the hypotenuse, which is the distance we want between A and B. So there would be our answer using the Pythagorean theorem on a triangle in the coordinate plane. This is also, go ahead and write this in, this is also a similar triangle by a scale factor of 2 to a 3, 4, 5 triangle. Draw it up here. And I would suggest that you kind of commit these two triangles to memory, because a lot of times you can answer the questions just if you know these. So we have a 3, 4, 5, which is similar to this triangle by a scale factor of 2. So 3 times 2 is 6, 4 times 2 is 8, and that would leave 5 times 2 to be 10. So I would try to commit the 3, 4, 5 and the 6, 8, 10 triangle to memory. All right, here's the other thing we can do. We can look at our answer choices. If we can determine this is the right triangle, which we can, we know that this side has to be longest. The hypotenuse has to be longer than the other two legs. So we can look at our answer choices. The square root of 14 is between 3 and 4, and so that's not going to be a possible answer. Choice B is 8, and 8 is one of the legs, so the hypotenuse can't be the same as the leg. It has to be larger, so we can mark it out. C was our correct answer there, and it is in fact larger than 6 and 8. And D, another choice, 20, it is larger than 6 and 8. So if we were just going to try to reason through this, we'd look at 10 and 20 and say, okay, these are possible answer choices. Now let me try to reason a little more. So if you were to imagine, let me see if I can get this to swing. If we were to, let's go and try to swing that. Well, it's not going to work. If we were to take this line A to B that I drew, and we were to swing it down where it would lay right on top of this line that was 8 units, we would notice that it's not very much longer than the 8 units that is there. It would come somewhere around where distance is on the page. It'd be right below there, and you can kind of see that. 20, that would be a little over 8 units. 20 units would be 8 units here, plus another 8 units would be somewhere down around here, and then another 2 units would be down below our answer choices. And if we swung that side out to meet this other side to form the triangle, well, that side would be way down here, somewhere over to the left of our answer choices. There's a little trick way you can do it also, is you can put a piece of paper up there or something to kind of mark how long is that distance. and then kind of stand it up on the where you're not going diagonally, but you're going straight up and down your coordinate plane, and kind of mark them off, and you can check them. So those are 3 ways where we can answer that question. We can recognize that it's a right triangle, use the Pythagorean theorem to find the hypotenuse. We can see that it is similar to a 3, 4, 5 special right triangle, and that this one is a 6, 8, 10, or we can look at our answer choices and kind of reason through that way. So use any one of those 3 strategies to try to answer these questions correctly.